Hello and good morning. Let's take a look here. First of all, today's date is 10/27, and let's take a look at these here. This one right here is the exterior angle theorem. Notice the angle is on the outside, and it's equal to the two remotes. Okay. This one right here is not a remote angle. This one is adjacent or supplementary. So you're going to say 2x is equal to x plus 30. And then you're going to solve that by subtracting x from both sides. And when you do, you get x equals 30 degrees. And there it is. And that's what you do. So this exterior angle is equal to the two remotes. Make sure you memorize that. This one right here is just a basic algebra equation. You have x's on both sides, so you're going to get rid of the smaller one, which is this one. So you're going to add 6 to both sides and get x equals 10. And that's how you do that. This one right here, you're going to separate the two triangles here. So one of them looks like this, and the other one looks like this. And so what you're going to do now is mark all of this. Well, this triangle looks like ACD, and this triangle looks like B, C, and E. And then they tell me that this bottom one here is equal to that bottom one. And you notice that this one has 2 marks here and 1 mark there. And this one has 2 marks here and 1 mark there. That would make these two equal by segment addition. So we're going to go ahead and mark these as equal. Okay, so now we have an angle and a side. And then finally, they both share this upper angle here. Right here, they overlap. They overlap at that angle, so that is called reflexive. And so these two triangles are now congruent by angle, angle, side. So angle, angle, side, triangles are congruent. Okay? Now what we're going to do today is, let's answer this one first. What does congruent means? It means the sides are congruent, or the sides are equal. So the sides are equal and the angles are equal. And that would be corresponding angles, the ones that match up. Okay, now let's do a little quick proof on this. So put away your bell work. On a new sheet of paper, we're going to do a proof on this one right here. This was number 3, so pay attention and copy this down. So put statement and reason. Okay, number 1, you're going to put everything that was given. Okay, in this case, they told me that that this angle right here, so angle CAD was congruent to angle CEB. Okay, and that's given. They also told us a couple other things here too. Let's take a look. If you look here, if you look at the original diagram here, they tell us that AF segment is congruent to EF, and they also tell us that BF segment is congruent to segment BF, it would be DF, and all of that is given. That's the first step. Okay, let's go to step 2. Step 2 is anything we can bring to the table. So we're now going to say that AD, and actually what we should do is probably add up these two by segment addition. So watch. We're going to say that AF, so segment AF plus segment FD is equal to segment EF. I'm going to move it up a little bit. Segment EF and BF. All right, and we're going to say segment addition postulate. All right, so we added that to it. We're also going to say that angle C is congruent to angle C. So step 3, angle C is congruent to itself by reflexive property. All right, I'm almost done. So now I have the sides equal. They gave us an angle. So step 4 is just going to be the triangles are congruent. And that's going to be angle, angle, sine. And that's a quick proof of what we did there. Okay? All right, let's keep moving here. On the next one, we're going to go on to a new section here, 5.1. So copy down everything that you see right there, 5.1. And we're doing the perpendicular bisector. And what that means is all points on the perpendicular bisector are equidistant to the two endpoints. In other words, if you take a point A and you take a point B, and then you take a bisector would be halfway, and perpendicular would be like that. So any point on this perpendicular bisector, that would be equal. Any point would be equal. So in other words, this one would be equal to this one. Okay? This one would be equal to this one. So any point on there, it's almost like wires on a telephone pole type of thing. Okay? So there you go. That's the perpendicular bisector theorem. What's the converse? Converse is switch. So put converse, and then let's switch them. Remember that CS? All right, so we're going to say if segments are congruent to the endpoints, then it is a perpendicular bisector. And there it is. So converse, you just switch that. We're going to go ahead and start a new section today because tomorrow you have a practice test on chapter 4. Friday, some kids are doing it in class, and the rest of you are doing it at home. Take a look here. This one right here is a perpendicular. And notice that this distance is equal to this distance, which makes it a nice isosceles triangle. But since these are equal, then it bisects the segment, and that's the converse. So you're going to say 5x minus 2 is equal to 2x plus 7, and then you're going to work that out. You're going to subtract 2x. And that's how you do that one, using the perpendicular bisector theorem. All right, let's move on now. Let's take a look at the workbook here. Go to page 202. I'm just going to go over a couple of these with you. So page 202. Okay. Let me make this a little bit bigger so we can see it. All right, so what's going on here? They want us to find, according to this, find OL. OL is this one right here. Okay, so first of all, this is equal and this is equal, so that would make this a perpendicular bisector. So the distance from here to here would have to be 14, which would be the same as that one. And then this is perpendicular bisector because these are equal distance to the endpoints. So this would have to be 7. 7 plus 7 would give you 14. So the answer there would be 7. All right, let's move on. Let's start talking about a little bit of today's work. So go to page 204. And I'm going to work a few of these with you, and then I'm going to get you started. So here we go. What is the relationship between a segment and the points on the perpendicular bisector? Well, draw a perpendicular bisector. And it says, what is the relationship between a segment and the points on a perpendicular bisector? Well, here's your segment. Any point on the perpendicular bisector will be the same distance to the endpoints. So write that down. They are the same, so A is the same distance to endpoint, or endpoints. Okay? And then B, between an angle and the endpoints, well, the angle is going to be equal. So this angle would be equal to that one. So put equal or congruent angles. Okay, number 2. How can you determine if a point is equidistant from an angle? Well, look here. Let's draw an angle. There's an angle right there. And how can you determine if the points are the same distance. Well, distance is always perpendicular. So in order for this distance to be equal to this distance, this angle here has to be equal to that angle. So it has to be an angle bisector. Okay? If you look here, what is the error? The error is this is not a right angle. See, it has to be a right angle to be a true distance. It can't be sideways. It's kind of like if you're standing up and you're slouching. You can't get the true height. It's got to be perpendicular, not slanted. Okay, so I don't see any boxes there, and that's the error. So not perpendicular. All right, with that in mind, I want you to work these. So 1 to 27 is today's work, and tomorrow you'll get your practice test. All right, we're going to move on now off of geometry, and we're turning our attention now to MCR. Let's take a look here. All right, so MCR students, copy that down right there, and let's work these. Well, this one right here is like terms, okay? So this, now you might say, well, what is like terms? So write this down. Like terms. Like terms have the same base and the same exponent. The same base and the same exponent. So here's the base here, and the exponent is 1. So this is going to be 5x. This one right here is like terms, so this is going to be 2x. These are not like terms because the exponents are different. So the answer is all of that. You can't do anything with it. Okay? They must be like terms. All right, let's go on. Copy these down right here on a new sheet of paper. And we're going on to 4.5. Tomorrow's a practice test. Friday is a test for some of you in class. This right here is like terms. So this is going to be 5x squared. This one right here is a plus. So you're going to add these two up right here. And you're going to get 5x squared. This one and this one is going to give you plus 4x. This one and this one is going to give you a negative 2. And then you're done. Okay? This one right here is a negative, but you have to distribute it. Make sure you distribute that. So put a star by that. So this is going to become, and I'm just going to change it up here. This is going to become a negative, and a positive. You can scratch these other signs out. Okay? So you're going to have 3x squared minus 2x squared is going to be 1x squared. This one right here is going to be 7 minus 3 is going to be 4x. And then this right here is going to be plus 6, and then you're done. And that's it. And here's today's work. And I'll see you guys in class.